Hello and welcome to a half projectile motion problem. In this problem, we have a ball rolling off of a cliff. And then it falls and hits the ground. The question is, how far will the ball land horizontally from the base of the cliff? That's the question. Now, the distance the ball lands away from the cliff is going to depend on the height of the cliff and the speed that the ball was traveling just before it leaves the cliff. So, those will be our two inputs. First input will be the speed it's traveling. Now look at the direction that it's traveling just as it leaves the cliff. Horizontal. Meaning that the initial velocity will be perfectly horizontal. Let's say that speed is 30 meters per second. That's its horizontal velocity. Now, we know that as the ball travels through the air, it's going to be moving at a constant speed horizontally, meaning if the ball had a shadow on the ground, that shadow is going to travel at a constant speed the entire time. So that's the first thing to note. The second piece of information that we will need is the height of the cliff. Let's say this cliff is 80 meters tall. 80 meters. It's a pretty tall cliff. You definitely wouldn't want to jump off of it. So the height of this cliff is 80 meters. That's the initial height. That's how far it's going to fall. So there we have it. We have our velocity, we have the height of the cliff, and we're looking for how far it travels. Now, the question is, what equation helps us find how far something moves? First of all, you must say, well, is that thing moving at a constant speed or a non-constant speed? If it's moving at a constant speed, then the horizontal distance is going to equal the speed it's traveling times the time that it travels. In this case, it'll be the horizontal speed times the peak time, meaning the time it takes to fall from the peak. So notice we already know one of these two. We need to find the other unknown, which is the peak time. So I hope you see that all we need to find is the peak time, and we have solved this problem. So let's find the peak time. Now the peak time means simply how long it's going to take to hit the ground. And it's important to note that no matter how fast the ball is traveling or how slow the ball is traveling horizontally, it's going to take the same amount of time to drop. So really the question is, how long would it take a ball to fall 80 meters? Well, what information do we have about its motion vertically? One is that its acceleration is negative 9.81 meters per second squared. We know that's its acceleration as it falls down. And we know that its displacement is 80 meters. So we know two pieces of information. Finding the third won't be too hard. We also know its initial velocity vertically is 0 meters per second. So from this information, we look to our four equations of kinematic motion, four equations of accelerated motion, and we come to this equation, that the height of the cliff is going to be equal to 1/2 times the acceleration times our unknown peak time squared plus the initial velocity vertically times the peak time. Now, before we even get further, we know the initial velocity right here, the initial velocity at point 1 is 0. Vertically, it's 0. It's not moving up and down. It's moving only horizontally. So that leaves us with this. So we must solve for the peak time. So when we do that, we solve for the peak time, we get the square root of 2 times delta D divided by A, and that gives us our peak time. Now we can actually plug some things in. We get the square root of 2 times 80 meters divided by, now this should be negative because it's falling 80 meters, it's not going up 80 meters, divided by negative 9.81 meters per second squared. So when we do that, we do in our calculators the square root of 2 times negative 80 divided by negative 9.81, and you get out 4.04 seconds. 4.04 seconds is equal to our change in time. All right, there we have it. We now know how long the ball's in the air. So we can take this time and plug it in here. So the horizontal velocity is 30 meters per second times the time of 4.04 seconds. Our seconds cancel, and 30 times 4.04 is equal to 121.2 meters. And that is our final answer. Now we can fill in what we have learned. 4.04 seconds is how long it took. There is no total time because it's not a full projectile motion. It's only half. We know its horizontal distance is 121.2 meters. We know that there's no launch velocity because it's not a projectile, a full projectile. And the last thing we could find is vertical velocity. That wouldn't be too hard. We'll solve that real quick. We know that the acceleration is equal to a change in velocity vertically divided by the change in time to the peak, which is now known. So, solving for those two things, we have acceleration times peak time is going to equal our change in velocity vertically. So, plugging that in, we have negative 9.81 meters per second squared times the change in time, which is 4.04 seconds. And that's going to equal our change in velocity vertically, 9.81 times 4.04. And we get out negative 39.6. Negative 39.6 meters per second is equal to our vertical velocity, the change. And since we know it started at 0 vertical velocity, we now know the final velocity is negative 39.6 meters per second. And that's that. There it is. All the elements of a half projectile motion problem.